Let's take a look at this example. Please notice that we have given current which goes through resistor R1. I1 is equal to the I total, okay? Because the total current will go through resistor R1. That's why I'm going to write that I total is equal I1, and this is equal 4 milliamps. Okay, I found I total, that's why I'm going to cross out I total. Next, I'm going to find the total resistance of these two resistors. Why? Because I want to find voltage across these two resistors. Okay, so I'm going to write that R23 is equal R2 times R3 over R2 plus R3. I'm using the formula called product over the sum because these two resistors are in parallel. So I have R2 is equal 5 kilo ohms times R3, which is equal 8 kilo ohms, over 5 kilo ohms plus 8 kilo ohms. This is equal 3.07 kilo ohms. Okay, so this is the total resistance of these two resistors together. Next, please notice that I can redraw the circuit, and I have something like this. I have resistor R1 and I have resistor R23, where R23 is combination of these two resistors. Please notice that we convert the series parallel circuit to the series circuit. Please also notice that we have given R total. Okay, so if I have given R total and I found the total resistance of these two resistors, I can find resistance R1. So I can write R1 is equal R total minus R23. I got this because you have to realize that R total for this series circuit is equal what? R1 plus R23. If you are going to solve this formula for R1, you are going to obtain this form. Okay, so I have R1 equals R total 10 kilo ohms minus R23 3.07 kilo ohms. This is equal 6.93 kilo ohms. This is the resistance of my resistor R1. Okay, so we found resistor R1. Now, next, the problem is asking me to find the voltage source. Okay, voltage source is equal I total times R total. Please notice that we have I total and we have given R total, so we can find very easy voltage source. Okay, the problem is asking me for voltage source. So I have I total is equal 4 milliamps times R total, which is equal 10 kilo ohms. Everything is equal 40 volts. So this is my voltage source. I can cross this out because I found voltage source. Next, the problem is asking me for voltage across resistor R1. Again, I'm going to use Ohm's law. V1 is equal current which goes through resistor R1 times the resistance of resistor R1. Okay, so this current times the resistance of resistor R1 will give me voltage across resistor 1. I found R1, I have I1, so plug in the values into the formula, and we will have 4 milliamps times R1, 6.93 kilohms. Everything is equal 27.72 volts. Okay, so this is the voltage across resistor R1. So I'm going to cross this out because we found it. Please notice that we have these two resistors in parallel, we said this already, and voltage across the components which are connected in parallel is the same, right? I mean, this voltage, voltage across resistor R2 is going to be equal to the voltage across resistor R3 because these two resistors are in parallel. In parallel circuit, the voltage across each component is the same. So I can write that V R 2, 3, other words we can also say this is V2, 3 is equal to the voltage across resistor 2. This is also equal to voltage across resistor 3. And this is equal, in this case, I total times resistance 2, 3. Okay, so keep in mind that this I total will also flow in this circuit. So I total, let me write this down, I total times the resistance of this resistor will give me voltage across this resistor. Voltage across this resistor is voltage across these two resistors. Okay, so I have I total is equal to 4 milliamps times R2 3.07 kilohms. Everything is equal 12.28 volts. Okay, so this is the voltage across resistor 2 and voltage across resistor 3. Next, we're supposed to find the current which goes through resistor R2. In order to do so, I'm going to use again Ohm's law for current. So I2 is equal V2 over R2, where V2 we set is equal 12.28 volts over R2, which is equal 5 kiloohms. Everything is equal 2.45 milliamps. Okay, so this is the current which will go through this resistor. Next, we're supposed to find the current which goes through resistor 3. Again, I'm going to use Ohm's law. I3 is equal voltage across resistor 3 over R3. This is equal 12.28 volts over R3, which is equal 8 kiloohms. This is equal 1.53 milliamps. Okay, so we found these two currents, right? The currents which goes through these two resistors. Now is good to verify if our answers are correct. Now we can use KCL and find I total by adding these two currents together. So I'm going to use KCL to verify these two answers. So I have I total is equal I2 plus I3, where I2 is equal 2.45 milliamps plus 1.53 milliamps. The answer is 3.98 milliamps, which is almost 4 milliamps. So it means that our answers up to this moment are okay. It's always good to verify some of your answers in order to check that you are on the right track. So we found I2, I3. Now we can find the power, P1. Okay, so I'm going to use space over here. So I have, just draw the border. So I have P1 is equal, I'm going to use the formula with the current, so I have I1 squared times resistor R1, where I1 is equal 4 milliamps raised to the second power times R1. We found R1 equals 6.93 kilohms. Everything is equal 110.88 milliwatts. Okay, so this is the power at resistor R1. Next, we're supposed to find the power at resistor 2. So P2 is going to equal I2 raised to the second power times R2. This is equal, the current which goes through resistor R2 is equal 2.45 milliamps. 2.45 milliamps. We have to raise this to the second power times the resistance of the resistor R2, which is equal 5 kiloohms. Everything is equal 30.01 milliwatts. Okay, and if you want to find P3 is equal I3 raised to the second power times R3, which is equal, current which goes through resistor R3 is equal 1.53 milliamps raised to the second power times resistance R3. We have 8 kiloohms. This is equal 18.72 milliwatts. Now we are ready to find the total power. P total is equal I total square times R total, where I total is equal 4 milliamps square times R total, which is equal 10 kiloohms. This is equal 160 milliwatts. Okay, you can verify this answer by adding these three powers. Okay, these three powers added together are going to give you P total. Okay, and if you are going to add them up, you're supposed to get the answer approximately equal to or equal to 160. If your answer is close to this answer, it means that the calculations are okay. I verify these answers. These answers added together are going to give me approximately 160, but I would like to ask you to check this one more time, and we can say that the problem is solved.